Okay, in this problem, we're going to have a horizontally launched ball from the edge of a table. Horizontally launched off the edge of the table. The table is 0.6 meters high, and the horizontal velocity that it leaves the table with is 2.4 meters per second. Okay? I'm designating that V naught horizontal. Okay? That's what I'm going to call that, V naught horizontal. What else do we know about this situation? We know that gravity is negative 9.8 meters per second squared. What else do we know about this? What do we know about the initial vertical velocity? Yeah, the initial vertical velocity equals 0 meters per second. Table's 0.6 meters high, leaves at 2.4 meters per second. Gravity is pulling it down at negative 9.8 meters per second squared. The initial vertical velocity is 0. Okay? So the first question we have is, how far from the table does it land? Was that the first question? Or was it how long is it in the air? How long it is in the air. What is the time this ball is in the air? T equals some sort of time that is in the air. Now, we need an equation, one of our 4 kinematic equations, that will help us decide or determine that time. And the equation we're going to need is D equals V naught T plus AT squared over 2. Now, we're talking about time in the vertical direction. This is an equation that's going to describe the vertical motion of the ball. The vertical distance is going to be 0.6 meters down. So we're going to call that distance negative 0.6 meters. What did we decide our initial vertical velocity was? 0. So what does this whole piece become? 0. So my equation then is D equals AT squared over 2. I'm solving for time, so I like to rearrange the equation first. And when I do, I get T equals the square root of 2D over G. Now, I changed A to G. I did a couple steps at one time. I multiplied D by 2, divided by A, which I changed to G, took the square root. Okay? So there's the equation that's going to give me the time. If I plug in my distance, negative 0.6 meters, I plug in my gravity, negative 9.8 meters per second squared, I get 0.35 seconds that the ball is in the air. So far, so good? Now, the next piece I want to know, Mr. Musio, is how far the ball lands from the edge of the table. This distance right here, a horizontal distance. The equation V equals D over T is all we need to know to figure that out. I know my initial horizontal velocity, and I know that my horizontal velocity does not change in projectile motion problems. That's one of the keys. Horizontal velocity does not change in projectile motion problems. This D is what I want to know. I know this time, so rearranging the equation, D equals V naught horizontal times time, which is 2.4 meters per second, times 0.35 seconds, which ends up being 2.4 times 0.35, 0.84 meters. That's how far from the table it's going to land. Kind of makes sense. The ball didn't leave the table very fast. It's not in the air very long. It doesn't even make it a meter away from the edge of the table. Makes sense. Now, the last thing I'd like us to determine in this kind of problem is the velocity that this thing hits the ground with. And it hits with some angle. And that makes sense with our prior knowledge. We know that if we roll something off the table with some velocity, it's going to hit the ground at some angle, whose components are made up of the horizontal velocity and the vertical velocity. I don't know this velocity, but I do know that V sub y final squared is going to equal V naught sub y squared plus 2ad. That's again from our kinematic equations. We know that our v naught in the vertical direction is 0, so that's going to be 0. I want to solve for this velocity, so my final velocity in the y direction is going to equal the square root of 2ad, which is the square root of 2 times negative 9.8 times negative 0.6. And the square root of 2 times negative 9.8 times negative 0.6, 3.43, actually we'll just go to 1 decimal point, 3.4 meters per second in the vertical direction. So now I know that my right triangle has legs of 2.4, 3.4, and that's the velocity I want. That velocity is going to be the square root of 2.4 squared plus 3.4 squared. The square root of 2.4 squared plus 3.4 squared equals 4.2 approximately meters per second. That's the velocity it's going to hit the ground at. One more thing I want to figure out is what is the angle it hits the ground at. We'll call it angle smiley face. And I'm going to squeeze this on this piece of paper. Angle smiley face is going to be the inverse tangent of our vertical component, 3.4, divided by our horizontal component, making sure that I am in degree mode. Second inverse tangent, 3.4 divided by 2.4, 54.8 degrees. So we have just described everything there is to know about this pool ball rolling off a table from a height of 0.6 meters with an initial horizontal velocity of 2 meters per second. We can figure all of the rest of this stuff out. Enjoy.